maintenance technicians.
The study of mathematics is basic to the training of the professional aviation maintenance technician. Throughout your career, you'll be required to make mathematical calculations that are vital to the successful completion of many tasks. With study and practice, these calculations may be made simply and easily, assuring the accuracy of your work. Among the most important of these calculations, used frequently in aviation maintenance, are the measurement of area and volume. Sheet metal for airframe repairs is ordered and sold by the square foot. Knowing exactly how much material to order for a particular job saves the customer and your employer money by eliminating waste. Engine horsepower is based in part on the cubic inch displacement or volume of the engine cylinders. First, let's consider the calculation of area. Everyday objects such as this wooden block are measured in 3 dimensions: length, width, and thickness or depth. In calculating the area of one surface of the block, we're concerned with only 2 of these dimensions, length and width. These 2 measurements describe a plane surface. A rectangle is a 4-sided plane surface with opposite sides equal in length and with 90-degree or right angles between adjacent sides. It's one of the simplest plane surfaces. The formula for calculating the area of a rectangle is length multiplied by width, L being the length of one of the sides and W being the width of one of the adjacent sides. In our example, the length of one side is 144 inches and the width of the other side is 48 inches. Multiplying, we find that the area of the rectangle is 6,912 square inches. Area measurements are described in square units. A square is a unique form of rectangle in which all sides are of equal length. The angle between adjacent sides is again 90 degrees. The calculation of the area of a square is done basically the same as that of the rectangle. Since all sides are the same length, we can give them all the same symbol, S. Simply multiply the length of one side by the same number. This is called squaring the number. Our formula for the area of a square becomes simply S squared. In our example, the length of each of the sides of our square is 3.25 inches. 3.25 inches multiplied by itself is 10.56 square inches. The area of our square is 10.56 square inches. The next figure we will consider is the triangle. A triangle is a 3-sided plane figure. The sum of the 3 angles in a triangle always equals 180 degrees. There are some interesting comparisons between the triangle and the rectangle that may help you better understand the method of calculating the area of the triangle. You'll notice that the rectangle has 4 angles that when added together equal 360 degrees. The sum of the 3 angles of a triangle add up to 180 degrees, or half of the angular measurement of the rectangle. The area of a triangle is equal to half of the area of a rectangle that would enclose it. Here's how that works. The 3 sides of a triangle are the base, indicated by the letter B, the altitude, shown here as the letter A, and the hypotenuse. For calculating the area, only the base and altitude measurements are necessary. If we were to enclose our triangle in a rectangle, we would see that the base and the altitude measurements are equivalent to the length and width measurements of the rectangle. However, the area of the triangle would only be half the area of the rectangle. Using the formula for calculating the area of a rectangle and substituting the base and altitude notations for the length and width of the rectangle, we see that the area of the triangle is the base multiplied by the altitude, that product divided by 2. This formula will work for the calculation of all triangles. We've just used an isosceles triangle for our example. An isosceles triangle is one in which 2 of the angles are equal. The formula will also work for calculating the area of a scalene triangle, in which none of the sides are of equal length. An obtuse triangle is one in which one of the angles is greater than 90 degrees. A triangle in which all of the sides are equal and all of the angles are equal is called an equilateral or equiangular triangle. An acute triangle is one in which all of the angles are less than 90 degrees. Let's calculate the area of an obtuse triangle whose base measures 10.5 inches and whose altitude is 2.2 inches. Multiplying 10.5 by 2.2, our product is 23.1. Now divide 23.1 by 2. Our result is 11.55 square inches. Next, we'll consider the parallelogram, a four-sided plane figure whose opposite sides are parallel and equal in length, but whose sides are not at right angles to each other. Calculation of the area of a parallelogram is a combination of the calculation of the area of a rectangle and a triangle. Again, we use the base and altitude measurements of the triangle, where the base is equal to the length of one of the sides, and the altitude is the length of a line drawn perpendicular to the baseline, extending to the opposite side of the parallelogram. The formula for calculating the area of a parallelogram is simply the base multiplied by the altitude. By separating the triangular portion of our parallelogram from the remainder and moving it to fill in the space at the opposite end, our figure becomes a rectangle with the same width and length measurements as the base and altitude of the parallelogram. The same amount of area or space is occupied by our converted parallelogram and our rectangle, only the shape has changed. For example, a parallelogram has a base measurement of 7.75 inches and an altitude of 3.25 inches. Multiplying the base times the altitude, our product is 25.1875 square inches. Finding the area of a trapezoid is somewhat more complicated, but can be made much simpler by relating it to the figures with which we are already familiar. A trapezoid is a four-sided plane figure having only two parallel sides. If we add another trapezoid the same size to our original figure, only inverted, we've constructed a parallelogram that's twice the area of the original trapezoid. The length of the base of the new figure becomes the sum of the base measurements b sub 1 and b sub 2. The altitude remains the same as in the original figure. We now can find the area of a parallelogram by multiplying the sum of the two base measurements by the altitude. Since we constructed the parallelogram from two trapezoids of equal size, we can now find the area of one of the trapezoids by dividing the area of the parallelogram by 2. The formula then for the area of a trapezoid becomes the sum of the two base measurements multiplied by the altitude, that product divided by 2. For example, a trapezoid measures 6 inches along its longer or major base and 2.5 inches along its shorter or minor base. Its altitude is 1 1/2 inches. Substituting in our formula, we find that 2.5 inches plus 6 inches is 8.5 inches. Multiply 8.5 inches by 1.5 inches to get 12.75 inches. Divide the product by 2, and we have the area of a trapezoid, which is 6.375 square inches. Now let's turn our attention to another figure, the circle. A circle is a plane, closed figure with every point on the line forming the edge of the circle an equal distance from a point within the circle, which is the center. The circumference of the circle is the distance around the edge of the circle from a point on the edge back to the same point. The diameter of a circle is the length of a straight line drawn from one side of the circle through the center point to the opposite side of the circle. The radius of a circle is the length of a line drawn from the center point of the circle to the edge of the circle. The circumference of a circle has a definite relationship to the diameter. This relationship is expressed by the Greek letter pi and is noted by this symbol. Pi represents the number 3.1416. This relationship will remain constant for all circles, regardless of size, and is expressed by the formula C equals pi times d, where C is the circumference and d is the diameter. In other words, the circumference of a circle will always be 3.1416 times its diameter. The area of a circle may be found by multiplying the constant pi by the square of the radius. For example, a circle has a radius of 3 inches, and you need to know the area of the circle. First, square the radius measurement, then multiply the product by the constant pi, 3.1416. The area of a circle with a 3-inch radius is 28.2744 square inches. So far, we've considered area measurement only in square units. However, it is often more useful to consider area in terms of circular units. The cross-sectional area of a piece of wire, for example, is measured in circular mils. A mil is 1,000 times a given measurement in inches. The formula for finding the area of a circle in circular mils is simply the area equals the square of the diameter in mils. Let's find the cross-sectional area of a wire 1/4 inch in diameter. We first convert the fraction 1/4 to the decimal 0.25. Multiplying 0.25 by 1,000, the diameter becomes 250 mils. Using our formula, the area is equal to the diameter in mils squared. The cross-sectional area of a wire with a diameter of 250 mils is 62,500 circular mils. Now let's turn our attention to the measurement of volume. So far, we've been working in only 2 dimensions. However, solid objects, as we've already learned, occupy space in 3 dimensions: length, width, and height. First, let's examine a rectangular solid. To find the area of one face of our wooden block, we multiplied the length times the width. To find the volume, we simply multiply that product by the measurement of the 3rd dimension, height. Our formula for finding the volume of a rectangular solid is the length times the width times the height. The result expressed in cubic units. A rectangular solid having a length of 24 inches, a width of 18 inches, and a height of 12 inches contains 5,184 cubic inches. A cube is a rectangular solid with all edges of equal length. The formula for finding the volume of a cube would then be the volume equals S sub 1 times S sub 2 times S sub 3. Since all sides are equal, the formula becomes simply S cubed. For example, a cube measuring 6 inches on each side would contain 216 cubic inches. Next, we'll consider the volume of a cylinder, a solid form having circular ends and parallel sides. First, we find the area of one of the circular ends by using the formula pi times the radius squared. We then multiply that product by the height of the cylinder. Suppose we need to know the volume of an 8-inch long section of aluminum rod with a diameter of 8 inches. First, find the area of one end of the rod by multiplying the radius squared by the constant pi, 3.1416. Then multiply the product by the length of the rod, 8 inches. The result is 402.12 cubic inches, the volume of our aluminum rod. Finally, let's consider the volume of a sphere. A sphere is a solid body whose surface boundaries are at an equal distance from the center point. A tennis ball is a sphere. A sphere is the shape which has the greatest volume for its surface area and is used in aircraft for such things as fire extinguisher and oxygen bottles and hydraulic accumulators. The volume of a sphere is found by multiplying the cube of its diameter by the constant 0.5236. This new constant is the result of dividing pi by 6. The volume of a sphere having a 6-inch diameter is 6 cubed, or 216, multiplied by the constant 0.5236. Our result is 113.1 cubic inches. Let's review some of the important points we've covered. The area of a rectangle is found by multiplying the length times the width. The area of a square is found by squaring the length of one side. The area of a triangle is found by multiplying the base times the altitude and dividing the product by 2. The area of a parallelogram is found by multiplying the base times the altitude. To find the area of a trapezoid, add the lengths of the major and minor bases, multiply the sum by the altitude, and divide the product by 2. We learned that in determining the area of a circle, we use the constant pi, which represents the number 3.1416. Pi expresses a relationship between the diameter of a circle and its circumference. That relationship is expressed as pi times the diameter. To find the area of a circle, we use the formula pi times the radius squared. To find the cross-sectional area of a wire in circular mills, multiply the diameter of the wire in inches by 1,000. The product is expressed in mils. Then simply square that result to obtain the area in circular mils. To calculate the volume of a rectangular solid, multiply its length times its width times its height. When the solid is a cube, simply cube the value of one side. The volume of a cylinder is found by first finding the area of one end of the cylinder using the formula A equals pi times the radius squared. Multiply the product by the height of the cylinder to find the volume. The volume of a sphere is found by using another constant, 0.5236, multiplying the constant by the cube of the diameter of the sphere. Practice with the formula and memorization of a few basic constants will increase your proficiency in the mathematical skills necessary for the professional aviation maintenance technician.